You know how your favorite shopping app can just instantly pull up your entire order history? Well, it all boils down to a huge choice in how we organize data. Do we want it to be perfectly, spotlessly tidy, or do we need it to be unbelievably fast? Today, we're jumping right into that exact tug of war.
Right, so every single time you shop online, book a flight, or just scroll through your social media feed, there's a database working away behind the scenes. It's really like the digital brain of the operation, storing and grabbing all the information that makes our modern world even possible.
And that question right there, that is the core dilemma. Do we organize that brain for perfect, pristine accuracy, making sure every single piece of information has one and only one home? Or do we set it up for lightning-fast recall, even if it means things get a little bit messy? This is the central conflict we're going to unpack today.
So, here's our game plan. We'll kick things off with the data dilemma itself. Then we're going to meet our two contenders: normalization, the tidy organizer, and denormalization, the quick assistant. After that, we'll put them head-to-head and finally figure out exactly when you should use each one.
Okay, let's dive in. It's time to properly introduce these two competing ideas. Now, they're not really enemies. Think of them more like two different tools for two very different jobs. Each one is just trying to solve the problem of managing data in the best way it knows how.
Let me break this down with an analogy that'll make perfect sense. Think of normalization as being super meticulous about tidying your room. Every book is on the shelf, every shirt is in its proper drawer. There are absolutely no duplicates lying around. Denormalization, on the other hand, that's like leaving your favorite book, your headphones, and maybe a snack right there on your desk. Why? Because it's easy to grab. It's all about convenience, not perfect order.
All right, let's get to know our first philosophy. You can think of normalization as the Marie Kondo of the database world. Its entire reason for being is to spark joy by getting rid of clutter and making sure every single piece of data has one logical place to live.
So what is normalization in, official terms? Well, it's a process for cutting down on data redundancy, which is really just a fancy way of saying getting rid of duplicates. And why do we do that? To improve data integrity, which just means making sure our data is reliable and consistent. To get this done, we follow a specific set of rules called normal forms.
These rules are kind of like levels of tidiness. First normal form is simple. Don't stuff a bunch of different things into one box. One piece of info per cell. Second normal form basically says that everything in a row has to be about that row's main identifier, its primary key. So everything in the apple row needs to be about apples. Makes sense, right? And third normal form just takes it one step further, making sure you're not storing extra info that doesn't belong, like the supplier's address in the product table. It's all about logical separation, which we're about to see in action.
Okay, let's make this real with a supermarket example. Here's our before picture. It's one giant messy table. Just look, if fresh fruit supplies, say, 10 different products, their name is repeated 10 times. Now what happens if they change their name? You have to go and update it in 10 different places. That's just asking for mistakes. So how do we clean this mess up? Boom! Step 1 is to create a table just for products. See? Each product gets its own unique ID, and we just use a supplier ID to link it to whoever supplies it. We're not repeating the supplier's name over and over again. It's so much cleaner. And this leads us perfectly to the next step. We create a whole other table just for suppliers. Now, if Fresh Fruits changes their contact info, we update it in exactly one spot. One and done. This is the real power of normalization. It makes keeping your data accurate so much easier.
And finally, to tie it all together, we have a sales table. It doesn't need to know the product name or the price. It just uses the product ID to point to the right item in the products table. Everything is separate, clean, and linked together with these simple IDs. That, my friends, is a beautifully organized database.
But what if tidiness isn't your #1 priority? What if all you care about is speed? Well, it's time to meet our second philosophy, denormalization, the quick assistant who is all about getting you answers and getting them to you fast. So denormalization actually breaks the rules of tidiness on purpose, and it does it for one reason: speed. This might mean we intentionally add some of that duplicate data back in. Or we might store pre-calculated totals so the computer doesn't have to do the math every single time. We might even merge those nice, neat tables back into one.
And would you look at that? We are right back to where we started with our original messy table. But here's the key. It's not a mistake anymore. It's a strategic choice. If a manager needs a quick sales report showing which products from which suppliers sold today, all the information is right here, in one place. There's no need for the computer to stitch 3 different tables together, which can be slow. The query is simple and the answer is fast.
Okay, so now that we've met both of our contenders, let's put them side by side. It's time for the showdown so we can see exactly where each one shines and where each one struggles.
And here it is, the big trade-off. With normalization, you get fantastic data integrity. It's reliable, it's easy to update, but the downside is that it can be slower to read information because the computer has to do all that work of joining tables. Denormalization is the exact opposite. You get blazing fast reads, but it comes at the cost of having duplicate data, and there's a much higher risk of things becoming inconsistent when you need to make updates.
So, who wins, normalization or denormalization? Well, the answer is neither of them. It completely depends on the job you need to do. It's not about which one is better overall, it's about picking the right tool for that specific task.
Okay, here's the bottom line. You're going to use normalization for systems where you're constantly writing and updating data, like a supermarket's inventory system or a banking app. Accuracy is absolutely king in those situations. And you're going to use denormalization for systems where you're mostly just reading data, like for business analytics or data warehouses. There, speed is the name of the game, because you need to generate those reports and insights as fast as possible.
And this isn't just theory. Check out this real-world example. The author of our source material worked with a major European railway. Now, to help them analyze all their ticket sales, which came from a bunch of different sources, the team intentionally denormalized the data. This gave the stakeholders much faster, clearer visibility into the key trends they cared about.
So really, the ultimate goal here is balance. Both of these techniques are absolutely essential tools in the toolbox. Great database design isn't about blindly following one philosophy over the other. It's about understanding the trade-offs and skillfully choosing when to be tidy and when to be fast.
And that kind of leaves us with one final big question to think about. For decades, this whole balancing act has been the foundation of database design. But now, as data gets bigger and faster than ever before, will we eventually need a totally new philosophy for organizing it all? It's definitely something to chew on. Thanks for joining us.